In this lecture, we are going to learn how to derive the formula of future value of an annuity. Actually, is an ordinary annuity. The periodic payment is $100. That means we put $100 in at the end. Remember, at the end of every period, and the capital R. That means the period, the interesting of every period is 2%. Remember, this is notice this is capital R. That means this is not annual interest. It is the period interest, periodic interest. The capital N is 12 to make this story to understand easily. I just give the real number. The compounding period is N is 12. So let's begin with the first $100. We put $100 at the end of the first period. What is the future value of this $100 at the end of 12 periods? At the end of this point of time? It's use the compound formula. Which formula? This one. Future value equals to the principal 1 plus capital R to the nth power. So for this $100, the future value at the end of 12th period obviously is the principal is 1,000. 1 plus the R is 2%. Or the principal is 100. And 2% to the nth power. This is a little bit tricky. Is 12 to the 12th power? No, because we put the $100 at the end of the first period. So actually the compounding period of this $100 is not 12, it is 11. 1, 2, 3, 4, 5, 6, 11 to 11. So how about this 100? We put this 100 at the end of the second period. How much we will get at this point of time? So use the same formula. It is 100 times 1 plus 2% to the what is the n? What's the real number here? We put the money at the end of second period. So how many periods for compounding the interest? 10. So do you find the pattern? Do you see the pattern? Yes, I think you job. So how about this one, the uh, 100? It shall be 100 times 1 plus 2% to the 9th power. How about this one? The $100 we put in at the end of 10th period. So it shall be 100 times 1 plus 2% to the, what is the number of exponent? It shall be 2. The pattern is the exponent here plus the number of the number of the periods shall 1 plus 11 shall be equals to 12. 2 plus 10, 12. 3 plus 9, 12. 10 plus 2, 12. So the same pattern. This shall be 100. This shall be 1. So if we put 100 at the end of 12 periods, it's just 100. Actually, you can write like this: 1 plus 2 to the 1 plus 2%, 0. The exponent is 0. If the exponent is 0, actually it is just 1. Just 100 because no compounding periods, no compounding. So it makes sense. Okay, don't make things look complicated. Okay, so for the future value of this annuity, we just add up all these expression. That means we just do the summation of every $100 future value. Do the summation in order to derive the formula. When I add up this expression, I put 100 in the first place. So this is, oh, excuse me. I want to make it look nicer. 100 plus this one plus dot 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 100 to the 10th power plus 100 times 1 plus 2% to the 11 power. So if we do the calculation, we can have a result, but we are now caring about the calculation. We care about generalize the pattern and derive the formula. So let's generalize the pattern. We denote the 100 as the letter P. So we have P plus P 1 plus the periodic interest rate, the capital R, the 1 plus P 1 plus R, the second power, plus dot 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 plus P to the 10 is N minus 2. Yeah, the 10 is N minus 2 because at the beginning we suppose capital N is 12. So if we are now generalize the pattern, so the 10 we use capital N minus 2 plus P one 11 is N minus 1. This is the future value. Oh, I need some space. Future value. P. Okay, barely get a space. A future value of an ordinary activity. So how to get the formula in the textbook? This is looks so long and so complicated. The tip is this equation for the both sides. We times 1 plus R to the both sides. So this P times parenthesis 1 plus R. We got here P. Oh no, at the beginning we better put the better simplify the formula before doing this. So the simplifies the formula. Okay. Oh, simplify the expression here. We take the P out and put the leftover in the bracket. So we got 1 plus tok, tok, tok. Plus okay, this looks cleaner. So write down. So we times 1 plus r to this on the both sides of this equation. So we got P here, and we times 1 plus r into this, into every turn of this blanket. So 1 times 1 plus r is here. 1 to the first power, remember. 1 times 1 plus r. We got this one. And this one times 1 plus r. We got 1 plus r to the second power. The same. If this one times 1 plus r, we got 1 plus r parenthesis to the third power. But I'm not going to write down all the term. I just denote. Tok, 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 tok. So for this one, this one times 1 plus r, we got here 1 times plus r and minus 1, because minus 2 plus 1 is minus 1, and this one times plus we got n. So we got this. Dot, 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 dot. Remember, there is, you better write down here. We shall have a 1 plus r to the n minus 2. How could we get this? Because there is a 1 plus r to the n minus 3 power here. So when it times 1 plus r, we got this one. So we use this equation, Fv 1 times 1 plus r minus Fv. That means this one minus this one, the P. We just put it out. Actually, we just calculate a whole bunch of terms in the blanket. Remember, minus this minus this one, a whole bunch of terms got cancelled out. 0 minus 1 is minus 1 plus this one minus this one cancel out. color. This one minus this one cancel out. This one minus this one cancel out. And cancel out. And cancel out. And the leftover is minus 1 plus this one. This term minus 0 is 1 plus 1 to the n power to make it look pretty. Just write down like this. 1 plus r to the n power minus 1. So this part, this side, cancel out. Look at this. FV future value minus future value cancel out. We just have FV times R equals to P so FV equals to P the R. Huh. So we finally got the formula. So if we do the reverse, we can figure out P, the periodic payment actually is equals to reverse the formula is the FV times both sides we times this one, we times R over 1 plus R to the n power minus 1. So we can calculate the periodic payment